Okay, today we're going to take a look at finding sides and angles using right triangle trigonometry, otherwise known as SOHCAHTOA. We can set up an equation and solve an equation, and then we can put our result into a calculator. That's going to give us a decimal result, which is approximate. So if I ask for an exact answer, that's going to indicate that we just put the answer in terms of a trig function or a calculator-ready form. So in example 1a, we have a 37-degree angle, we have 2, which is the adjacent side, and we have x, which is the opposite side. That would imply that we're going to use a tangent equation. So tangent of 37 degrees is equal to the opposite x over the adjacent 2, and then we can solve for x by multiplying both sides by 2. That will give us x is equal to 2 tangent of 37 degrees. That's our calculator-ready form. In B, we have a 59-degree angle, we have 5, which is opposite to it, and we have K, which is the hypotenuse of that right triangle. So we can set up a sine ratio, or a sine function. Sine of 59 degrees is equal to 5, which is the opposite, over K, which is the hypotenuse. Now our variable's in the denominator, but we're still going to go ahead and multiply through by the denominator. That gives us K times the sine of 59 degrees is equal to 5. Next, to solve for K, we can divide by sine of 59 degrees, and that'll give us K is equal to 5 over the sine of 59 degrees. And there again is our exact form or calculator-ready answer. Moving ahead, we can find an angle in a right triangle using inverse trigonometric functions. And that'll again be our calculator-ready form. So in example 2a, we are looking for angle A. We have the side of 3, which is the adjacent side to angle A, and we have 5, which is the hypotenuse. That indicates that we're going to use a sine ratio. So sine of angle A is equal to the adjacent 3 over the hypotenuse 5. A quick tip, whenever you're taking the sine, cosine, or tangent of anything, that anything that you're taking the sine, cosine, or tangent of must be an angle. Now, in order to isolate the measure of angle A, or undo that sine function, we're going to use an inverse sine function. So the measure of angle A is equal to the sine inverse of 3/5. There's our calculator-ready form. In example 2b, we have angle P, 4, which is adjacent to angle P, and the square root of 7, which is opposite to angle P. That indicates that we're going to use a tangent ratio. Tangent of angle P is equal to the opposite, square root of 7, over the adjacent 4. In order to solve for the measure of angle P, we need to undo the tangent or use an inverse tangent. So measure of angle P is equal to the inverse tangent of the square root of 7 over 4. And there again is our calculator-ready form. Try the two examples below. Here are their solutions. Moving on to example 3, this is not a right triangle. However, there's a height in the right triangle. I'm sorry, there's a height inside of the triangle, and the height hits the opposite side at a right angle. So we can do this in a couple of different ways. We can approach it the way that we have before with trigonometry. And the thing about using SOHCAHTOA or right triangle trigonometry is we must have a right triangle. Looking at that little highlighted portion of the triangle, we do have a right triangle inside of the big triangle. There's a 60-degree angle h is opposite, and h8 is the hypotenuse of that right triangle. So using trigonometry, sine of 60 degrees is equal to the opposite h over the hypotenuse 8, which means that h is equal to 8 times the sine of 60 degrees. There's another way to approach this, and that is by using special right triangles. Below the 30, 60, 90 triangle that is highlighted, I'm going to draw another 30, 60, 90 triangle, and I'm going to insert the sides that we know that go with that 30, 60, 90 triangle, 1, square root of 3, and 2. I'm going to use a similar triangles proportion. So h corresponds to the side that measures square root of 3 in the other triangle, and 8 corresponds with the side that measures 2 in the other triangle. Cross multiplying, we have 2 times h is equal to 8 times the square root of 3. Dividing both sides by 2, h is 4 times the square root of 3. Now, which one of these expressions seems simpler? 4 times the square root of 3 is clearly simpler because it doesn't have a trig function involved. So when we can use special right triangles, you definitely need to do so. So in C, we're going to use the simpler of those two expressions, the 4 times the square root of 3, to find the area of the entire triangle. So the area of a triangle, as we know, is 1/2 times base times height. The base of this triangle is 12, and the height, which is perpendicular to it, is 4 times the square root of 3. 1/2 times 12 is 6, times 4 is 24, times the square root of 3. So our area is 24 times the square root of 3. Try the example below and just find the height of this triangle. And the hint is find a right triangle that will help you find h, and then use SOHCAHTOA. The answer is, as you can see, our answer depends upon finding that supplementary angle to the 110 degrees. That gives us the 70 degrees inside of the right triangle. Moving on to finding distances indirectly in applied problems, we know that from geometry, we have an angle of elevation and an angle of depression that measures how far down or up we are looking. And remember that one side of the angle of elevation or depression is always a horizontal line. So in example 4, I have a plane flying at an altitude of 5 miles. I'm going to go ahead and draw that in to our figure. The altitude is the height of 5 miles. And it's beginning its approach to the runway. So here's the ground, the horizontal distance. And the approach to the runway is at an angle of depression of 12 degrees. Now, if the plane were flying straight ahead and not landing, it would have a 0-degree angle of depression. But since it is going to have to head toward the airport, the angle of depression is 12 degrees. That's frequently something that's mislabeled. Remember that it's going to be outside of the triangle. Now, remember that the ground is parallel, so we have a set of alternate interior angles here, and 12 degrees is also that alternate interior angle measure inside of the triangle. We'll make the assumption in these types of problems that the ground is horizontal and heights are vertical, so therefore we have a right angle. Now, what we're looking for in this problem is the distance directly from the plane to the runway. So that would be this distance if the nose of the plane is heading toward the runway. So we have a 12-degree angle, we have an opposite side 5, and we have a hypotenuse x. That's going to be a sine type of equation. So you can write sine of 12 degrees is equal to 5 over x multiply through by the denominator. X sine 12 degrees is equal to 5, and then divide by sine 12. X is equal to 5 over sine of 12 degrees. And since x is a distance, it's going to be measured in the same units as the height or of the plane or the altitude, miles. In example 5, we have a student casting a shadow. She is 5'3" tall. The shadow is 8'4" long. Now, it's going to be to our advantage to use one single measurement unit here instead of feet and inches. Let's just use feet. Now, we've got a height. She's 5'3", which is 5 3/12 of a foot. Improper fractions are best. That would be 12 times 5 is 60, plus 3 is 63/12 of a foot. So her height is 63/12. And then the shadow is 8'4", which is 8 4/12. 12 times 8 is 96, plus 4 is 100. So we've got 112 feet. So her shadow is 112 feet long. We are looking for the angle of elevation of the sun. So we're looking for this angle right here. And we have opposite and adjacent. So we need to write a tangent ratio. Tangent of x is equal to opposite, which would be 63/12 over adjacent 112. We can simplify that division. That would be 63/12 times 12 100ths. Our 12s will cancel, and that's going to give us 63 100ths. So x is equal to the inverse tangent of 63 100ths. And thinking about what that's going to be measured in, we're going to get an answer that's measured in degrees. That's it for today.